In this particular example, we will take a look at solving for the reaction forces given a pin and a roller and a single point load. In this case, we will use our static equilibrium equations that we have learned about in the previous examples. Our static equilibrium equations are the sum of the moments is equal to 0, the sum of the forces in the x direction is equal to 0, and the sum of the forces in the y direction is equal to 0. If we remember, a pin can be represented as two different reaction forces. A reaction force acting in the x direction, in this case RAX, and a reaction force acting in the y direction, in this case RAY. A roller, however, can only resist motion in one direction and is free to move in the other. In this case, a roller is denoted by the single force RBY, which is acting in the y direction. We will begin to use our three static equilibrium equations to solve for our three external forces. The first equation that we will use is the sum of the moments is equal to 0. If we remember, a moment is equal to a force times its perpendicular distance. In this case, if we take our pivot point about point A, we will eliminate two of our three unknowns, allowing us to solve for RBY. The distance between RAX and the pivot point and RAY and the pivot point would then be 0. Our first force that will cause a moment about point A would be the 150-pound load, which is acting 4 feet away from the pivot point. So we take 150 pounds and multiply it by its distance, 4. And then we have to think about its sign. So, we will use our right-hand rule in this case. As we see, if we use the right-hand rule, we see that it has a negative sign. Also, we can tell that it is negative because it is causing the beam to rotate in a clockwise direction. The second moment, acting about point A, will be generated by force RBY. We say that RBY's perpendicular distance from the pivot point is 10 feet. In this case, RBY is causing the beam to rotate in the counterclockwise direction, and using the right-hand rule, we can see that the moment generated is positive. Simplifying our equation, we will see that 0 is equal to negative 600 plus RBY times 10. Rearranging our equation, we will add 600 to both sides. And finally divide both sides by 10. We will see that we get a final answer of RBY is equal to 60 pounds. The next equation that we will use is the sum of the forces in the x direction. As we see, we only have one force acting in the x direction. So by default, and just looking at this problem, we can tell that RAX is probably going to be equal to 0 because there is nothing to resist its force coming from the other direction. The final equation of equilibrium that we have left to use is sum of the forces in the y direction is equal to 0. The three forces acting in the y direction are as follows. RAY is acting in the positive direction. RBY is also acting in the positive direction. And we have a negative 150 pound force. It's a negative because it's acting in the downward direction. In the previous step, we solved for RBY and found out that RBY's value is 60 pounds. So substituting into our equation, we have 0 is equal to RAY plus 60 minus 150. Simplifying our equation, we have 0 is equal to RAY minus 90. When we add 90 to both sides, we get that RAY is equal to 90 lbs. So our final answer should be RBY is equal to 60 pounds. RAX is equal to 0 pounds because there are no other forces acting in the x direction to resist its motion. And RAY is equal to 90 pounds.